Hello. Today we are going to learn about how Java can help us in making use of regular expressions. Now, in order to make use of regular expressions, Java provides us with various inbuilt classes such as the pattern class and the matcher class. We shall later on move forward and see what each of these classes do. But keep in mind that Java provides this util.regex package, and all of the required classes and things, whatever you require for making use of regular expressions in Java, is provided within this package. So let us first of all import everything that's there in this. Then we shall take the util package as a whole, just in case we need something else. Let's create the main method. Now, whenever you make use of regular expressions, all that you need is a regular expression and you need a string which you want to compare against this regular expression. That is, a regular expression is basically some set of rules and you want to see whether or not this string conforms to this regular expression. Okay, so in order to do that, there is a pretty simple way. There is a class which is known as the pattern class, and it contains a static method which is the matches method. This matches method takes a regular expression as its first argument, okay, and it takes a string as its second argument, and it returns a boolean value. So let us take a boolean value. It returns a boolean value which tells us whether or not this input string matches this regular expression, or rather whether or not this input string is conforming to this regular expression. That is, whether or not it is according to whatever is specified here. So let us test that out. Let us first of all create a regular expression. We are going to create a very simple regular expression here, just for the purposes of getting an example at our hands. So yeah, this is the regular expression, and let the input string be something like AB. Okay. So what this regular expression says is that this is a two-letter string, and the first letter can be anything between a small a and a small z inclusive, and the second letter is also something between a to z inclusive. So as you can guess that this string quite clearly conforms to this regular expression, and what it should return is a true value. So let us see whether or not this works properly. And we print out the boolean value. Let's compile the program. There it is. So yeah, as expected, this string conforms to this regular expression. Now let us try out something else. Let us say that the regular expression is something like, or let us say that the string is something like this, 900 AB. So as you can guess, I think that this string is never going to conform to this regex, because all that this regex requires is two characters, and each of them should be a lowercase letter, essentially lowercase English letter. But naturally, the first two characters here belong to the class of digits, and so it's not going to conform to this regex. Let us see whether or not what this program returns us is according to how we analyzed it. Yeah, so it returns as a false, which means that this string does not conform to this regex. So as you can see that this matches function is a very basic functionality. It just tells us whether or not this string conforms to this regex. That's all. Now say suppose you had a long sentence. Okay, you had a very long sentence such as I scored 9,000 runs in test match cricket. Okay, so if you see again, if you run this program, naturally it is going to return false because the first character does not conform to this, and neither does the second one. It's a space and this is not a small character at all. But what if you wanted to find out all of the places where this string conforms with this regex? So what I mean to say is, maybe you wanted to find out the first occurrence of two small letters in this string. That is what this regex means, right? This regex means that you want to find two small characters consecutively in your input string. So what if you wanted to find out all occurrences of two consecutive small characters, such as SC, CO, RE, or OR, ED, etc. in your input string? So that is something that should be provided by Java, and as you can guess that it is provided. It's just that this matches method is very primitive, and it just says whether or not the string as a whole complies to this regex. But in order to use the added functionality, we have to make use of a different approach. There is this inbuilt class again, and there is another method here, which is the compile method. Now what this takes in is a regular expression. Okay, so let's create the regular expression that we want, like this. That is what we wanted, that is what we had before. Let's pass it here, and this returns us a pattern object. Okay, now there is another class which is called the matcher class, and this matcher class, believe me, this is very advanced in comparison to the simple matches function that we saw before. Using the object of this matcher class, you can perform many advanced things, such as finding out the occurrences of a particular substring which confirms to this regex in your input string, finding where that occurrence starts, where that occurrence ends, and all of those things. We are going to see all of that. So to get an object of this matcher class, we need to make use of another method, which is the matcher method, and it takes this pattern object as its parameter. Oh, sorry. It takes another different string as its parameter, and this is going to be your input string, the string that you want to compare against this regex. So let's take the input string as the same thing. I scored, it should be SCORED 9000. Well, yeah, in test match cricket. That's a lie, by the way. Okay, so now what we are going to do is let's first of all see this function. So see, unlike the previous case where we were using the matches method, in this case we see that this string and this regular expression, when used in this way, gives us a true value. Why is that? Well, that is because this find function does not match this complete string exactly with this regex. That is, it does not find out whether or not this string as a whole complies with this regex. That is, it is not finding out whether or not this whole string complies to this regex, right? So instead, what this find is doing is that it is finding out whether or not there exists some substring here that complies with this regex. And as you can guess, there are numerous such substrings here which contain two consecutive small letters, and we can see that here. Okay. So another thing is that you can also find out where this match has been found. That is, int start is equal to r.start, int end is equal to r.end. Okay. Let us print these variables out and see what is it that we get. Yeah, so have a look at this. The start value is 2 and the end value is 4. Let us see what is at the second, this 2 index. So 0, 1, 2, 3, 4. That is this 2 to 4 substring. So we all know that substrings do not include the last character, that is 2 inclusive but 4 non-inclusive, right? So S and C, yeah. So this is the first match. Okay, but how do you find out the additional matches? Well, so for doing that, all that you need to do is run r.find again. Okay, and again give the start as r.start, give the end as r.end, and now we should be able to see the second match. See, it's 4, 6. So S, C, 0, 1, 2, 3, 4, 5. This is the string that it's telling. So this is the first capture and this is the second capture. So as it turns out, it does not match overlapping strings in one case. So if this group has been captured by this regular expression, this CO is not done anymore. It's just this complete substring is overlooked and the next match is found. Alright, so you can think of it in this way, that once this group is captured, when you run the next find function, this remaining portion of the string is matched with this regular expression, or rather it is found whether or not, or the test is run so that we find any occurrence of 2 consecutive letters in the remaining portion of the string. Alright, so that is how it is done. So how do you find out all of such occurrences? Well, to do that, just by seeing how this behaved right now, we could run a loop. So while we can find out the presence of an occurrence in this string, or rather any particular substring, right, we are going to get the start index of that capture as r.start and the end of that capture as r.end, and print it out. Now this should give us all of the possible substrings. Not all of the possible, but yeah, I would say non-overlapping captures. So yes, we've got all of the non-overlapping captures, or rather non-overlapping substrings within the string that conform to this given regex. So 2 to 4 is 1, which is this substring, then 4 to 6 is 1, then 6 to 8 is 1, then naturally all of this is excluded, and so there is this big gap from here to here. And then it's again 14 to 16, then again from 16 to 18, and so on. So yes, that's how you can do, you can find out all of the possible places in which the string has any particular substring that conforms to this regex.